All right, so today we're doing, again, section 3.2, solving systems by substitution. Again, the idea is to substitute into other equations to get your solutions, to find x and then y. Now, I want to remind you guys that whenever you solve a system of equations, your answers are always points, okay? So let me just kind of put that right here. Solutions are always points. Okay, in other words, an x and a y. The reason why I'm reminding you guys about this is because every year when I grade these quizzes, people find the answer to x, but they never give me the answer for y. Or maybe they find the answer for y, but they never tell me what x is. So you got to give me two answers, okay? The reason why it's two answers is because essentially what you're solving is for a point of intersection, right? A point of intersection. That's what you're trying to find. So that means your answer has to be a point, right? An x and a y. So solutions always have to be a point for this stuff. Now, there's no like new way of learning something. There's no like lesson involved here. We're going to work on examples. That's how I teach you guys this process, okay? There is no like do this step, etc. I guess we could kind of develop one, but let me show you guys what I mean. So we're going to solve each system by substitution. Okay, those are going to be my instructions for this. Okay, solve each system by substitution. And here's example one. Now again, we're going to start easy and then medium, then difficult, right? Or I guess if you want to call it that. But I know on your homework, they're going to write it like this. So I'm going to start with one that doesn't look very nice, okay? But this one is considered an easier problem, okay? It is considered an easier problem, but it's not going to look nice. This is the way they're going to show it to you guys in your homework, okay? One on top of the other. The first thing I'm going to suggest for you guys, if you want to make this a little easier on yourself, is to write them side by side. Whenever you do substitution, don't write it one on top of the other. Write it side to side. So let me rewrite this. Y equals half x plus 1, and y equals 3x minus 4. Now guys, the numbers can get a little weird sometimes, so the use of a calculator is kind of important, okay? For some of these, you might end up with fractions and stuff like that, so using a calculator will probably be a good idea. So, ideally, after you put them side by side, you want to solve one equation for y, but notice they're actually both solved for y. So what I'm going to say is, okay, if y is equal to half x plus 1 and y is equal to 3x minus 4, then let me get this. So I'm going to kind of highlight it here. Let me get this piece of information, and I'm going to plug that in where that y is. Because according to my problem, y is half x plus 1. Okay? So let me rewrite that. Half x plus 1 equals to 3x minus 4. That's what's called substitution. I got the value for y from one equation and plugged it into the value for y in another equation. Now you can do that for x as well, but for us it was already solved for y. So there you go. We have substitution. Now all we have to do is combine our terms and solve. So I want to get my x's together, so let me subtract half x from both sides. Now notice, this is why I'm saying you might want to use a calculator, because if you're not comfortable subtracting by fractions, then you might want to have your calculator do it for you. So on the left side I have just a 1 equal to 3 minus a half. So if you got $3 and you take away 50 cents, you have $2.50, right? 2.5, or 5 over 2 x minus 4. Again, a calculator will give you that same answer, okay, 5 over 2. Now add 4 to both sides. So you get 5 equals to 5 over 2x. Do you guys remember how to get rid of a fraction in front of a variable? We did it in a lesson, maybe 2 lessons ago. I mean, I could divide both sides by 5 halves, but remember I told you, let's try not to divide by 5 halves. There's a little trick. The reciprocal, you multiply by the reciprocal, right? Multiply by 2/5. That's the fastest way to do it, okay? And the reason why we do that is because whenever you multiply a number times its reciprocal, so 5 halves times 2/5, it cancels out. And all you're left with is an x value. And on the right side, 2/5 times 5 is 2. Now, this is not my full answer because remember what I told you guys, your solutions are supposed to be points. But this is my x value. To find my y value, I'm going to plug it back in to my original equation. Okay, I'm going to plug it back into my original equation, and then I can solve for y. So I'm going to change the color to blue here, because if you're looking at my notes, I want you to notice, okay, we went from highlighted to a green, then my equation turned to green and red, so now I see where I plugged everything in. We did all the work in red up until a different type of thing occurred, right? So I used that green. I'm going to go back and change colors again, just so you can see, like, we didn't do all the left side at one time, right? I don't want you to confuse it with he worked on everything on the left, because right now there's only one little thing on the left side. But right now when I plug in the work, you're going to see more work. I want you to notice that's not what we did immediately, right? So that's why I'm trying to draw arrows to kind of guide you. So y equals half times 2 plus 1. And half times 2, that's a 1. And 1 plus 1 is 2. So my answer for y is 2. So, if you leave it like that, you are correct. But remember, the answer is a point. That's not a point. Okay? A point would be x is 2, y is 2. This is the solution you should give me. Okay? And I'm going to be very forgiving on your quizzes. If you could at least give me the x and the y value listed, I'm going to be ecstatic because you did it. Okay? But if you really want to put it in the right format, it has to look like this. Okay? Because remember what I put at the very top. The solution to a system of equations is a point. Not just two variables with values on the side. It's an actual point. You got to give me the point. Okay? So if I can just review this really quick. We started with two equations. Y equals half x plus 1. Y equals 3x minus 4. You're supposed to solve for y or for x, whatever you find to be easiest. But you got to solve for a variable. Now for us, they were both already solved. So what I did is I got the left side equation, the half x plus 1, plugged it into the right side equation. So we got the half x plus 1 equals 3x minus 4. I solved for x. That's all the stuff on the right side. I solved for x. I got x equals 2. Then I drew an arrow back, basically telling you, now that you know what x is, figure out what y is by plugging it back in. That's the stuff in blue, right? That's me plugging it back in and finding the value of y. Okay? Now I got x, I got y, so let's just put them together as a point, and then you're done. Okay? This is a long process. Graphing might be faster, okay? But I can tell you for a fact that I know my answer is 2, 2. I didn't get it wrong. Whereas if I would have graphed it, if I had a line that was a little crooked, my answer may have not come out to 2, 2. Okay? So this is a better way of solving. This is exact, whereas graphing is approximate. Okay? So much better way to do it. So that's actually question number 2 on your homework. If you want to write down like number 2, that's question number 2. I could have done an easier one, but I figured let's do one with a fraction, right? That way you guys can see that we did one that's a little bit on the tougher side. Now before I move on, which I know I kind of scrolled up already, are there any questions with this one? Because again, we call this one easy because they're both solved for y. Hold on, let me see. Yes,
If you solve 2x on the right side, could you put like the 2x on the right side again, or do you have to put it on the left side?
You can put it back on the right side again, but most people like to go around in a circle. So they say, I started here, I went there, and now I'm going to go back, right? I guess you could think Lion King, right? The circle of life, right? That's what's basically happening. You're going around in a big old circle. So most people will always plug it back into the original one. It's just habitually the way it goes. But no, you can plug it into either one. It should work for both. Mm-hmm. You got it? Okay. Yeah, but most people will always go back to them. Yeah, and you don't have to. That's what he was just mentioning. Could I have plugged it back into 3x minus 4? You could have. You could have done that. But like I said, there's so much work on the right side, most people will go to the other one because now there's room, right? So they'll go to the other one just to plug it in. You get the same answer either way. Any other questions? Mm-hmm.
If you had 2 and 1/2 instead of 5/2, would it change the answer?
No, it would not. It would just look a little weird because then you're going to divide by 2.5. But that's okay. Your calculator knows how to do it. I mean, you can change it to a fraction. So he was just asking, instead of me putting 5/2x, could you have written 2.5 or 2.5, right? You're going to put 2.5. Same thing. It's not going to change your answer. It'll be the same. So if you don't like fractions, do 5 divided by 2, 2.5. Okay, there you go. Let me put 2.5 instead. That's okay. Any other questions? I mean, this is basically it, like this one example, but I want to do something medium difficulty for you guys, okay? And then we're going to try doing one hard difficulty, and then we'll be done. So again, I'm going to write it out the way they do it in your homework. Okay, they like to write one on top of the other. I really don't like that because for substitution, I prefer them to be side by side. So I'm going to write them side by side. Okay? So that's going to be one of your homework problems right here. Let me write them side by side. Y equals negative 3x minus 12. I'm sorry. Oh yeah, that's right. And then 2x minus y equals to negative 13. So the reason why I call this one medium difficulty is because they're both not solved for y. Only one of them is. Okay? So that means that you probably have a good idea which one to substitute where, because the first thing you want to do is solve for y. Now, since it's already solved for y on one of them, then that part's done. What I want to do is get this piece that's solved for y, and I want to plug it in to the other equation right there. But guys, there's something that's a little tricky about this. When I plug it into that y, notice how there's a minus in the front of it? That means you're going to have to distribute it, okay? That's why whenever I plug stuff in, I always tell you I put a parenthesis around the stuff I plug in so that I don't mess up the math. You're going to see a perfect example of that right now. Look, 2x minus parenthesis negative 3x minus 12 equals negative 13. Notice how me putting a parenthesis is going to force me to distribute. I'm going to have to distribute that negative. All right, so that's why every time I plug numbers in, you're going to see me putting in parentheses around whatever I plug in. All right, because I want to make sure that I don't mess up because I was just being careless. All right, so let's go ahead and simplify here. We got 2x plus 3x plus 12 equals negative 13. Well, 2x plus 3x, that's 5x, plus 12 equals negative 13, right? At this point, teachers should be confident that you can solve this, right? Let's subtract 12 on both sides. So we got 5x equals, say again? Negative 25, but yeah, that's the right value, 25. But we're going to negative 25. So if I divide both sides by 5, what do I get as an answer? Negative 5, right? So, all right, x equals negative 5. So good. I got an answer, but notice an answer, not the answer, right? Just one of the two. I need x and y. All right, I need x and y. So I need to get this and substitute it back. So again, why do I put it to the first equation instead of like what Santiago said, why don't you just put it back in the old one? Because the right side's all full of work, right? So I'd rather just work on the left side that's kind of empty, right? So that's why I do it. There's no other reason than just trying to be neat, right? Trying to put things in order right there, right? So I'm going to plug in the -5 in where the x is, okay? So again, I'm changing color here. Y equals -3 times -5 minus 12. -3 times -5 is a positive 15. And 15 minus 12 is 3. Again, my answers are correct, but they're not in the correct format. I need a point. So my point will be -5, comma 3. All right, there's my answer. That's the point that if I were to graph these on a coordinate plane, that's where they're going to pass. -5, 3. They're going to crash into each other at that point right there. Okay? Any questions on this one? Let me kind of go back up. So remember, the easy one was easy because they were both solved for y, not because the work was simple. No, no, no. I call them easy because there's minimal work to start. Okay? The medium ones are medium because one is solved for, and then when you plug it into the other equation, it actually ends up embedded inside of it. So you can see how the green portion, the -3x minus 12, that's within the equation, not just on the side, it's like inside of it. So I say that's a little bit more difficult because it looks weirder, right? So maybe it's a medium difficulty. So let me show you one that is, I guess they would say the hard type. Go ahead.
So you only need one equation to solve for y?
Or x, yeah, you could solve for y or x. Most people always solve for y, but x sometimes is easier depending on what it looks like, what the equation looks like. Yeah, I could have, so the question, if you guys didn't hear him, was, could I have not gotten the 2x minus y equal -13 and solved that one for y, right? Hold on, I'm not sure if I'm hearing you. So turn the second one into a what?
Add the 13.
Oh, move this over and then move the y over here? Yeah. So you could have solved, that's what I meant by solving for y, like moving it over. You could have totally done that, and if you would have done that, you could have actually plugged it in that way too. You could have gone that way or just left it like that. I mean, again, well, I don't know if you guys see it, but that's the beauty of mathematics, is you can do things however you want. Just don't break any of the rules, right? If you're going to move things around, go ahead. Just make sure you move them around by adding and subtracting things properly. You can plug them in any direction, left to right, right to left. Who cares? Just don't break the rules. You'll be fine. You'll still get the same answers. Yeah. I can do some crazy stuff to the right side and then still plug it in, and you'll see I'll still get -5, 3, as long as I don't mess up my math, right? If I don't add wrong, I don't forget to distribute, right? That's one of the things that I like about mathematics. It's black and white basically, right? Like you're either right or you're wrong. You can get from point A to point B however you want, right? If I tell you let's go from here to let's go to the Boyo Loco over here, right? You can go around, take Lark Allen, you can go over here to the front, you can jump a fence. It doesn't matter. We can all get to the same place, right? The way you get there can be different. That, like I said, that's what I like about math. It allows you to think your way through stuff, and you can do whatever you like. We should still end up at the same place, right? So, yeah, there's many ways we could start this and end this problem. Yeah, tons of different ways. That's why calculus, a lot of students that take calculus, they get scared because there's so many ways that they now can do things, and they're not sure which way is the right way. And I'm like, there's no right way. Your way is the right way. Now figure out how to get there, right? And they get really scared because they've never been told that you can do a problem however you want. Go for it, right? And they get really worried about it because they're like, no, aren't you supposed to give me all like 10 steps? I'm like, no, use your own steps, right? And then they start to like panic. So yeah, it's kind of interesting. But that, to me, that's the fun part in math. Again, that's for me the fun part in math, because it does give you freedom, and no matter what you do it right, you're gonna still get the right answers. It doesn't matter, right? So all right, so I'm gonna give you one that is considered a hard problem. And if I'm looking at this correctly, it might actually be an interesting problem at the end. Let's see. I'm not sure if this is going to do what I think it might do. Why would I call this one a hard problem compared to the other ones? What do you think, Brandon? Go ahead. Nothing is solved, right? Nothing is solved. You can solve for y, you can solve for x, for any of the equations, whatever you want. Okay? You get to choose which equation you want to solve for. Now, there's one I would prefer. Let me rewrite these side by side really quick. But I'll do whatever you guys want. Okay? I'm not going to force you to do it my way. But I may ask you why. So, we look at these equations. We got an equation on the left, an equation on the right. Which one looks like it might be the easiest equation to start with in order to solve for a variable? Left or right side? The which one? The right side. Why would you say that? Well, there's no, okay, so I like that. There's no negatives on it. I'm in his field here. I don't like lots of negatives. So if I don't have to deal with them, I'm not going to deal with them. I would also pick the right side, but not really because of the negatives though. The y is alone. You see how the y doesn't have a number in front of it? That means I'm not going to have to divide anything at the end, right? Anytime you have a number in front of a letter, you always have to divide it out at the end, right? I don't have to do that. Let me go ahead and solve for y. I'm going to subtract 3x. So yeah, that would be my choice, the right side, and solve for y. But we could have solved for y on the left side too. It doesn't matter. So look, here we go. I solved for y. Let me highlight that, because that's going to be what I'm going to be substituting. Okay? So now what I'm going to do is I'm going to get this, and I'm going to plug it in right there, where that other y is. And yeah, things are going to get a little messy. And if I'm right, they're going to get a little interesting too. But let's see. So I'm going to go ahead and plug it in. So I get negative 9x minus 3, parenthesis, negative 3x plus 4, and parenthesis, equal to negative 3. Again, I want to plug it in using a parenthesis so that I know that I have to multiply. If there's a negative, if there's numbers, I know that I should multiply it in. Okay? So I do have to distribute right here. Negative 3 times those two things. So I'm going to get negative 9x plus 9x minus 12 equals negative 3. Now, what I was expecting to happen actually happened, so that's good, because I was hoping I was going to get to do one of these. All right. What happens on the left side? It cancels out. Negative 9x plus 9x, that's gone. So look what I have. Negative 12 is equal to negative 3. Well, does that make any sense? So if that's a false statement, remember, say it again. No solution. Yeah. If this is false, so thank you for that, you're going to write no solution. If there's no solution, what kind of lines are these? Let's see if you guys remember yesterday's lesson. Go ahead, David. Parallel. They're parallel lines. That means if I would have solved the other equation for y, they both would have had a slope of negative 3. If I would have done that. I didn't, because I'm lazy and I don't want to. Okay? I just want to plug it in. But notice it was false, so it's no solution. Okay? I'm going to write right here in blue. if true. So let's pretend that you went through and you did all the work, and exactly what happened here, you know, the 9x is canceled, but let's just pretend that it said like 1 is equal to 1. And that's a true statement. What do you think my answer is supposed to be if it's a true statement? So if it's false, we said no solution. Or we can solve it and get one answer. Which one's missing? Remember, there's 3 types. There's infinitely many solutions, right? We're missing that one. If it comes out true, if I cancel out everything, and my final thing says like 5 equals 5, or -6 equals -6, and you're like, well, that's true. If it's true, you're going to write IMS, infinitely many solutions. That means that the equations must have been identical to begin with. Maybe you couldn't see it, but if you would have solved for y, they would have been exactly the same for both. Okay? So that's what you guys are doing for homework for today.